All right. Okay, so under week 6, I posted project, I don't know, requirements and guidelines. So maybe I'll just spend a few minutes going over this, and then we can take a look at, I don't know, Python stuff later. So I don't know if you saw, I posted this, I uploaded it last night, but I accidentally uploaded the wrong version. Like I made updates to it, but then I uploaded the wrong file. Like, it happens to all of us. So I uploaded the wrong file. So if you saw it last night, it was the wrong version, okay? This is revisions that I've made based on the projects I got in the spring, and I said, okay, I need to fix this. All right, so it's gonna be graded out of 400 points, okay? There's 2 parts, gonna be a written report worth 250, and the presentation and video worth 150 points, okay? So as far as the written report goes, there's going to be 3 sections. Background information, context, and description of the data. That's worth 75 points. And then exploratory data analysis will be 100 points, and then data modeling will be 75 points, okay? We haven't, as far as our course content, we haven't gotten to the data modeling stuff yet, okay? But I think there's been enough covered to at least do the first 2 parts, the EDA and then the background part is the other stuff, right? Okay, so I said this a little bit on Friday, but I'll go over it here with everyone's here, okay? So as far as data selection goes, you can use pretty much any data set you can find. And I would say the minimum number of observations should be around 40, okay? Probably ideal number will be a couple hundred to a couple thousand, okay? But if you find something that you're really excited about and there's only a few observations, I don't want that to be to make you feel like you can't use that data set, okay? So I'll say we'll put a lower bound at 40, and then you gotta include at least a link to the data set somewhere online, or upload a copy of it to your GitHub repository, okay? If you don't own if it's not like in the public domain or something, just check about like putting copyrighted stuff in your GitHub. You don't want to be breaking any rules, okay? And then, and this is the important part, is that you are required to pick data from a subject about which at least one person in your group has to be knowledgeable about it, or at least very interested in this data set, okay? So, the example I use is, if you choose to use the wine data set in Kaggle, someone in your project group has to be knowledgeable about wine, okay? I don't want just 3 people who knows nothing about wine saying, here's a good data set, let's analyze this, right? Like, somebody should know the difference between like a Merlot and a Cabernet, or whatever, at least what the terms dry and sweet and all of that stuff means, because that plays an important part in the data analysis, your background information. So, whatever I'm imagining, or I'm hoping, the groups you form, at least like some people are friends in there, and generally friends share some common interests, usually. And so, there might be something there, right? Like if you're really into basketball and you want to use basketball stats, then that's great, okay? I want something that's interesting to you. If you're like into, like last quarter, somebody was really into like League of Legends, and they found a League of Legends data set on like tournament, I don't know, stuff. But it was good because the person was like really into it, and they could explain like, whatever it meant when the tower fell down, and and all of that stuff, right? As somebody who has very little knowledge on the subject, that would not be a good data set to explore. So at least one person in the group needs to know and be in a position to explain the subtleties to notice, okay? All right, so the first section is background information, including context and description of the data. So if you look at the parts, this is weighted just as heavily as the data modeling section, okay? So a lot of people spent a lot of time in the data modeling section, and I felt like they didn't give enough attention to this background thing. So I'm trying to weight it appropriately because it is important that where your data is coming from and just general knowledge. Like again, if you're into League of Legends and you're looking at tournament gameplay and stuff like that, you should explain how the game works, right? And just information about that, because that's important in order to extract knowledge from some kind of data. So there might be things that are thought to be common knowledge, but it's generally only common knowledge for people who are familiar with the subject. So, for example, I did something about like baseball, and there might be people who are relatively unfamiliar with baseball, and the idea of what a hit is versus an at bat and getting on base, like there's all some differences there, and anybody who's a fan of baseball knows these differences, but they're only common knowledge for the people who are in the in-group, okay? So I said, I'm not going to do a word count, but my guideline is something around 700 words, probably 1,000 words, which is a few pages of stuff. It's not something that should be just like, here's 2 paragraphs to introduce the data. That's not going to cut it. So you do need a thorough section here, okay? And then I would say the biggest part will be the exploratory analysis of the data. This is where you will pretty much almost all of this part, the exploratory analysis of the data, can be done in pandas, and I think you've got enough in your tool set, or at least we've covered enough, and I've at least shown you the tools to get started on this part, where you can look up each of the variables, create bar charts and scatter plots and things of that nature. This part should be guided by a series of questions or curiosities, okay? So in the report, there you should be, as you're exploring, I'm hoping it's not just, hey, like for example, in the Titanic data set, like I don't know if you guys are familiar with this, but there's a data set for Titanic, and if you take the entire data set, it's less interesting to just say like how many people were in first class, how many people were in second class, how many people were in third class, okay? More interesting would be what was the survival rate for those in first class versus third class? What impact did being in first class have based on survival rate? So see if there's a relationship there. And then I think also another interesting question would be, so if you look at the data set, and if you kind of say like who's an adult and who's a child, there's definitely correlation or a relationship between survival rates and age group, okay? Where there's kind of this idea of women and children first, and as far as loading up the lifeboats, and I think it would be a curious thing to explore, what age would have been considered child versus an adult, right? Is there a stark difference between people who are 18 and younger, or is it people who are 16 and younger? Probably in this case, because there was the cultural and social thing for women and children first. What is the appropriate groups to explore for the survival rate here?
Women in first class. Class divided.
I would actually say if you want to explore this as far as seeing what age might be considered a child versus an adult, would be you'd look at the men, okay, males, and you want to see survival rate of, say, like boys 10 years old and versus over 10 years versus, boys 14 and younger versus like maybe 13 and younger versus 14 and older, or 15, 14 and younger and 15 and older or something. And if you can find a spot where this is the age at which boys didn't make it onto the lifeboat, I think that would give some insight into, at least during that time period, who was considered to be an adult, like an adult quote man that wasn't worthy, or wasn't quote entitled to be on the lifeboat, right? I think these are interesting questions to explore, and these are the types of questions I want you to ask and answer in the exploratory data analysis section. Okay. It's not interesting just to make like 50% survived and whatever, 50% died or something like that. That's less interesting. Something where there is a question and it shows your thought process. Okay. Ideally, my hope is that when you finish this project, you'll have some kind of thing that's on GitHub that you're proud of, that you can show possible future employers, or whoever else, your thought process. And I would say it's much less impressive to just see like charts without any kind of thinking behind them. So definitely include your thought process there, and see that. Okay. So that section's worth 100 points. And then the last part is data modeling. And I guess we'll get into this, but this is where you're going to start doing either predictive, fit a model or make predictions based on things. If you're going to make predictions, you want to split your data up into test and training, things like that. And we'll talk about some of the ways to fit things. You're allowed to use any model here, okay? You probably have stats knowledge of the more traditional models like linear regression and ANOVA and those things, but if you want to start fitting, if you want to use XGBoost or random forest or whatever you want, that's open, okay? And then here we got a slide and video presentation. And so as far as that goes, the report, the audience for the report is basically me, all right? So you can assume I have knowledge of, statistical theory and stuff. So you don't have to worry about trying to explain exactly what random forest is doing or things like that. But as far as the slide and video presentation, I want you guys to think of maybe more of a general audience, okay? And if you want to tailor your technical report to be a little bit more general, especially if you want to show, people outside of this class, then that's fine. But the slide and video presentation, I definitely want to encourage you to put more for a general audience, and I'm going to be grading you based on clarity and how concise you can be, how well you can explain things, and are you doing anything unnecessary, okay? And then in the video, It's just going to be a video of you giving your presentation, basically, okay? Some of you have video editing skills, okay? That's great. It's not a requirement, okay? If you want to just stand next to a screen and go through the slide presentation, that's fine. And someone's recording on their phone, you know, that's adequate, okay? It just needs to be at least professional in the sense that it's rehearsed, okay? Yeah, I don't want people to be stumbling in the middle of their presentation, and you know, if you're going to record it somewhere, like do it somewhere quiet where there's not a whole bunch of background noise or things like that, and definitely the audio needs to be clear. But okay, are there questions on all of this? Yeah.
For the video, could we just kind of do something like you do, where we just have like the screen being recorded and we talk over it, or do we need to be?
I would like to see some faces. You know, if you can do what I do, and you can put like a little. Oh,
okay.
Like you can use the front-facing camera or something in there. I think that's better. Yeah, I know. When you watch my videos, I'm not in the thing, but sometimes a
face is on the profile picture. But
I guess so.
Same
Yeah,
thing,
yeah.
You're not
So
speaking.
I'm not speaking. Yeah, I guess I would like to see some face when I hear the speaking. Yeah. Yes.
Also, if we want to use a data set that's really big, like 10 million rows, can we just sample from it and then use that smaller data set for analysis?
Yes. Let me see. Okay. When you sample from it, though, I might not recommend just pure random sampling, depending on what it is that you're going to be doing. Okay. It might be more informative to say, I'm going to just sample 1 month of data. Okay? When you do that, you're going to lose the ability to kind of make comparisons over time, or like overall time trends. Or maybe the thing you're going for is time trends, but then sample, I don't know, you know, group A or whatever it is, okay? Especially if it's something like 10 million and you're only going to be sampling, I don't know, how many, think like 100,000 or something, you know, like, you know, when you're sampling like less than 1% of the entire data set, you're subject to a lot of the randomness induced by the random sampling process, and you might miss important structure in the data. So you can come talk, and then I'll try to give you my advice as far as like how you should approach the sampling part and to kind of reducing the size of your data. Yeah. Okay. Are there other questions? Yeah.
Does everybody have to talk? Or...
No. If just one person in the group wants to talk and do the presentation, then that's fine. Okay. I won't force that. That's not part of the grading. Okay. And it is a group project, and I'm very well aware of the potential, I don't know, dynamic problems of a group, okay? Like with four people, there's a possibility that, well, there's always a possibility that one person shoulders all of the burden. I don't want that to be a problem, okay? I don't want people to hate group projects, and you know, if you work, you're always going to be doing it. Everything's a group project, pretty much, okay? There's only rare circumstances where you are the only person ever on something. You know, if the issues are coming significant, you know, you guys can come to me as a group, and you know, I can act as a mediator or something. The goal is to get I mean, everyone in the group's going to be assigned the same grade, okay? But I don't want the burden to just fall on like one individual in the group. And if it feels like that's doing something, or if someone's not carrying their weight, let me know, okay? That you know, I'm not out to like punish people or anything like that, but it is important that people contribute. Okay. Other questions regarding the final project? All right. Anybody find an interesting data set that they're excited about? Not yet? Okay, but you will? I was debating whether I should make a deadline for picking a data set, like just so you don't start the project during the 10th week. If you maybe we'll say by I don't know. Okay.
Or are we fine to use like outside like libraries and packages we haven't talked about?
Yeah. You're welcome to use whatever's out there. Okay. This is that's out there. Okay. All right. I'm gonna just, I guess, do a little bit on Matplotlib, and we'll see. We'll see what we cover. And then also just PSA, make sure you do occasionally run conda update all on your machines to update all of the packages and stuff. So I think day names was like a function that some people couldn't run, and it was because they had an older version of whatever. Pandas on their machine. Okay, so this is Matplotlib, and I think we've seen some of it already, but I'll go ahead and just talk about it. So Matplotlib is basically a Python implementation of what how the author perceived the graphics capabilities of MATLAB. Okay, and so MATLAB is not something that we use a whole lot in the stats department. Maybe the engineering classes use MATLAB a little bit more, but some of the function calls look similar to MATLAB. Okay. Anyway, you're gonna import Matplotlib pyplot, and the general alias is plt. Okay. And so here I'm just going to do use NumPy to create an array that goes from 0 to 2 pi that has a length of 500. So np.linspace, and then we're going to call the sign function on that and create y, and then and if I just do plt.plot in Jupyter, it'll produce this, okay, x and y. You can add other things, such as here's the title, sign of x, and in here if I say x limit 0 to 4, then it will cut off at x is 4, and plt show is basically like the print of it is basically print for plots. Okay, so the default is just plt.plot. Okay, And so here's a array range 0 through 4, okay? And then here I just said, random numbers from 0 through 10, and so I get 60958. And so the default is to connect these using, if you just say plt.plot, it'll connect them, okay, with lines. Okay, and if you don't want that, you do a plt.scatter, okay, and it's the exact same data, x and y, except instead of connecting them with lines, you get points, right? And so it very much changes almost like the nature of the graph. It's the exact same data, but it just feels very different from this. So anyway, scatter plot, plt.scatter, right? Histograms are available using plt.hist, and you can say bins is equal to 30. I always get these are like habits that are hard to break. I always want to type in breaks, or like in R, I'm always typing in bins, and I'm like, why is this not working? Bins and breaks. So anyway, you got this, right? So you can change this 3 bins, which is like the worst histogram. This probably 13 bins is appropriate. Here's 30, and here's 300. Okay. So anyway, histograms there. You can add multiple functions. You just keep calling plot, all right? So in R, generally you call plot, and then you call lines to add these things. Here you just keep calling plot, and it keeps adding them to the graph until you call show, okay? So here, x is going to be 0 through 2 pi, and then our y function will be the sine function, z will be the tangent function, and w will be cosine. All right, and so this just creates the vectors or the arrays of values. And so if I call plt plot and show, it's going to plot x and y and x and z. So it's going to plot the sine and then the tangent function, and then and we have that, right? So you can't even see the sine because the range on the tangent function is so extreme. And truly it goes off to positive and negative infinity, but why doesn't it go up to positive or negative infinity here? It's just because I'm linearly spaced values at like 500. I don't know what the actual x values here are, but it's not actually pi over 2 or things like that. It's something close, and so the tangent function is extreme, but not actually plus or minus infinity here. Okay, and then as soon as you call plot show, it kind of clears out the plot buffer. And so if I call plot show there, I can call this, and I don't know, you plot these things, right? So then you can provide it argument names like the color that you want, and whatever else. Pretty much, a lot of color names work. Like if I say navy blue, I think maybe this might error, this might work. Okay, so it doesn't like navy blue, but I think navy works, right? And you can always look up, maybe I already have this listed. Maybe not, okay. You can always look up Matplotlib colors. Color names. So these are all the things you have. There's navy, there's dark blue, and medium blue, dark red, maroon, misty rose. That's a... All right, let's see what that is. I guess I already saw. All right. Clearly. Okay. you can also use subplots, okay? So if you don't want them on the same plot, you create a subplot, and it's going to be the number of rows, the number of columns, and which plot you want to draw, okay? You just have to be careful. This uses Matlab indexing, which starts at 1. So you got so subplot 2, 2, 1 will say we're going to create basically 4 plots here, okay, or spaces for 4. And so in the top left corner, we're going to draw x versus y, which is sine of x, and then subplot 2, so going to the next one will be the upper right. We're going to put in cosine of x, and then 2, 2, 3, we'll put in the lower left tangent of x, okay? And so here you've got your subplots. Unfortunately, well, I don't know. The tangent of x title kind of runs into it there, right? So that's subplots. You can modify your labels and axes using the title and the your x label and y label options. Okay. So here we've got sine of x, x versus f of x. Okay, axis equal here. This is kind of like the aspect ratio. And so if you plotted a circle, it would look like an actual circle versus fitting the axes to fit the bounds here. Okay. Okay, and then here, if I just zoom in on 0 to 2, this is the start of this sine function, but created as a scatter plot. Okay, as always, you can just look up Matplotlib documentation, and there's all sorts of arguments here. Okay, the color, the marker. Default is O, but you have other options here. So the default is to use O here. Whoops. Marker style. What is going on here? Oh. Okay, so you can change marker to O. You can use the dot, which will make smaller dots. Okay, so O is that, dot is this, and then you can, color is maroon. Okay. I think you can also use like triangles. So these are kind of the different options you can use. What is I don't know what D is. I'm just curious. Diamonds, that's what they are. Square diamonds and narrow diamonds. All right, well that's fascinating. All right, so here if I can do x, y, what was the one for cosine? W. What are my color names? Dark slate gray. All right. This is This is not that exciting, but all right. Hexagons for capital H. All right, I can't even tell the difference between hexagons and circles, but there they are. Okay. So you can do it that way. All right. You can even plot two-dimensional functions. So here I've got x and y. All right. And so when you create, you can use something called mesh grid, and it basically it'll see that x has the length of here, actually I should do print x and print capital Y. All right, so here I'm taking the values 0, 1, 2 and -1, 0, 1, and 2, and when you create mesh grid, it's going to send back two arrays here. Okay, it sees that x has a length of 3, y has a length of 4, and so x, y together will be 4 rows and 3 columns, and it has duplicated the x across the rows. So we have 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So it broadcasts x into a 4x3 array, and then for y it broadcasts the y, which was -1, 0, 1, 2, into also a 4x3 array. Okay, but it does y column what is it, row wise, and it does y column wise and x row wise. Okay, so I don't know if you guys can see this. So 0, 1, 2 gets broadcast this way, and -1, 0, 1, 2, which is y, gets broadcast the other way. And that way, I guess I did do it right here. And that way you can create function calls that will create kind of the intersection between the first value of x and the first value of x and the first value of y, and then the second value of x and the first value of y, and by aligning this 4x3 grid and this 4x3 grid, you'll have every interaction between x and y there. Okay, so for example, you can just say, give me back x times y, and we create the mesh grid on x, y, and then z will be basically the result of basically doing 0 times -1, 1 times -1, 2 times -1, and then at the next row 0 times 0, 1 times 0, 2 times 0, 0 times 1, 1 times 1, and 2 times 1, and so on and so forth, and we get this, right? This is similar to doing the function outer in R. In R you have outer, where you just take a vector x and a vector y, and it does the outer multiplication there. Here, you're calling this. You could do, you could define your function however you want. Here we're doing plus, okay, and if you do that, you would get something different. Okay, and so anyway, for example, I'm going to take the values from -3 to 3, and then I'm going to create a mesh grid x and y here. Okay, so I'm going to get basically an array that's 101 by 101 here. Okay, because x is from -3 to 3 with a length of 101. Y is -3 to 3 with a length of 101. Okay, and then does this look familiar? I've got NumPy, so I'm saying, just calling the exponentiation function e to the -x squared multiplied by e to the -y squared. Okay, so x star 2 is x squared and y squared, right? So e to a negative quadratic, what does that look like? Yeah, it's going to be proportional to Gaussian, right? So Gaussian is like 1 over square root 2 pi or whatever. It's just some kind of normalizing constant, so it integrates to 1, multiplied by e to the basically a negative quadratic, e to the -x squared. Okay. Okay, so I'm doing, so this is going to be, we've got a Gaussian for x multiplied by a Gaussian for y, or something similar to that. And so we will get what? A multivariate Gaussian, but because they're independent, it'll be the independent case, right? So in that case, when I do this, z is going to be an array 101 by 101. If I just say z shape 101 by 101, and then contour will create contour plots, right? And so here this is a contour plot of, I don't know, your bivariate Gaussian, standard normal there, almost standard normal. ImShow will kind of create a heat map-ish looking thing, and this is basically your Gaussian densities here. Okay. All right. That's just a very quick intro to Matplotlib as far as two-dimensional functions and stuff goes. Okay. Just restart and run everything.